One is rock excavation laboratory that we will visit definitely after the end of this session. And this is dedicated rock mechanics lab. We have different setup you will visit. You will ask our senior technician Mr. Munsi and Mr. Mandal. They will help you to give you about the introduction about the machines. Today what we have planned to give you some glimpse about the different instrument facility we have available in this laboratory. One, we will test uniaxial. We will load the rock sample uniaxially to determine the UCS. Another test we will do the rock in not truth axial but basically the biaxial with cylindrical core in this machine. Both same machine but the cell is different. The third test we will do with the indirect tensile strength determination test setup, because we do not have direct tensile test setup. I doubt in India it is not available also. Majority of the cases we use indirect tensile strength, that is Brazilian. We will test with that. That is also mostly Russian manufactured machine. More than 50 to 60 years it is giving the service to this department. And last, the most useful index we use for rock engineering is point load index. That has already been dealt by Professor Brassi to you. The useful of this point load index. At the end, we will test our sample at this point load index. Point load index setup. We have this setup. We have two setup. So one we will test. So these are the 4 tests we will conduct. And remember what we have given you the suggestion. Before and after, you should not forget to take the snaps of the sample, so that from the test itself you can see, you can predict, you can decide, you can conclude whether the test is good after the limit or test is wrong, it is not acceptable. So after that, based on that, we will again discuss in our tutorial classes, even in the lecture classes. So please give the attention. Mr. Munsi will guide you and give you the brief introduction of about the machines, different machines we have. And basically first we will start with uniaxial one, then biaxial one, then we will switch over to the indirect tensile strength setup, and the last to the point load index setup. So he will elaborate. He is our laboratory senior laboratory technician serving for department for more than 30 years, and he have lot of experience for testing different kind of rock for a different site throughout India, and you can have a very good idea about responses of rock under different loading conditions. So I request Munsi Babu to give you this introduction.
To start with, we will conduct this uniaxial compressive strength of a rock. Generally, you have to follow some standards. We follow ISRM standards, International Society of Rock Mechanics. As per the suggested method to conduct uniaxial compressive strength, you have to test at least 5 to 7 specimens. So naturally, with a very short period of time, it will not be possible. So we just show you one specimen, just to acquainted with the procedure only, how to conduct. Okay. So as per ISRM suggested method, you require a specimen of index size, that is 54 mm dia with 2.5 to 3 times length. Okay. Why this is required? That they have clarified in their manual and in their standard. Why 2.5 to 3? Why not 2? Why not 4? They have clarified in their manual. If you go with your ISRM method, you will find there. Okay. So 2.5 to 3 times of the diameter is the requirement, and surface after cutting the specimen. One important thing is that is specimen preparation in rock mechanics or geomechanics practical is very, very important. For that, we have a very good specimen preparation laboratory. From a block, how you have to take out a core specimen, drill core specimen of required diameter. That is very important. If you require a angular drilling, you require that facility also. Then you have to cut both the end faces, you have to prepare the specimen as per your required length. Then smoothness of the specimen, all are very, very important in rock mechanics. So you require a very good specimen preparation laboratory first. Okay. Now we have already prepared a specimen to demonstrate you how to measure a uniaxial compressive strength. So we have I will give you this digital caliper only just to show how much is the diameter and length. We place the specimen in between two loading plates. This is a 600-ton compression testing machine. We place this specimen in between two plates, start loading at a required loading rate or stress rate, okay, and load it up to the failure point. Then breaking load divided by the area, that is my compressive strength. It's a very simple thing, but preparation and then observation of the specimen and how the failure occurs, that is also a very important part. Different type of failure as per your requirement. One is sedimentary rock, failure pattern will be different. Metamorphic rock, failure pattern will be different. Okay, so you have to observe that failure pattern, whether your result will be accepted or discarded depending upon your failure pattern. And when you are going for 5 to 7 specimen you are going to test, you have to see all the failure patterns, then you have to judge which one is perfect and which one is because of that weak plane, a pre-existing weak plane or joint plane. Okay. To start with, just compressive strength, uniaxial compressive strength. Uniaxial means in one direction you are giving the uniform load. That is uniaxial. Then we go for triaxial. How the specimen behaves when you are confining the specimen. Okay. In uniaxial, there is no confinement. That is zero confinement. When you go for triaxial, you have to confine the specimen. That means you have to give some hydraulic pressure. Then you increase your sigma 1, that is your axial load. That is triaxial load. That also I will show you next. Okay. So to start, you please write down so that you can calculate and you can take how much is my uniaxial compressive strength.
This is the digital one. Generally, we use earlier
Manual also
one.
we have. This is digital caliper. Please write down the diameter of the specimen is 54.54 millimeter. 54.54. And the length is 139.29. Ready? Wait.
875.
875 gram is the weight of the specimen. And rock type is Charlo.
Yes, you are doing the right thing. Filling the rock. Better way of taking the snap is like this. Different direction you take. Take this way. Not this way, this way, this way. Lower pattern. Load cell. It is load cell. Load cell. See the setup. We have put load cell at the bottom, and we will put load from the top. No,
Name of this machine is, please write down. Name of this machine is compression testing machine. Compression testing machine with 600 ton capacity. you can apply 600 ton capacity. In any compression testing machine, you will find two loading platens. These are called the loading platens. This is upper loading platen and this one is lower loading platen. Lower loading platen will go up, and as per your specimen length, this will be adjusted. If you want to test a long specimen, generally with this machine we do the test of hydraulic legs used in the long wall gallery. Okay. For that, this upper loading pattern will go up to 3 meter length. This is the biggest facility of this machine. You can accommodate of anything with up to 3 meter length. Okay. Now we will lowering down this upper loading pattern, touched with that specimen, and below the specimen we have placed a load cell. It's an electronic load cell, strain gauge based. Directly you can load and get the load here also. But to get the time dependent curve along with load, we have connected this load cell with a data logger. And from the computer with the software, you will get a time dependent curve of load versus time. So different time, how the load behaves. How the load behaves means initial loading, with respect to time, how the load is behaving. It may be your loading rate will be faster, where it will get constant. Initially what will happen when you apply load, the voids and pores inside the specimen will get compressed. Okay. Then it will act as a solid. Then in the finally, when it reaches to the failure point, before failure point, you will find the loading rate you are not increasing, but it will automatically it go increase. So by that curve, the time dependent load curve, you can analyze. So for that only we have placed this load cell along with a data logger and a software that is called Catman Express, that software.
Put the operators, so that one will see how load rate is going on, and Babu will be in the machine to see the rate. खाने लिए खाने बस 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 so that both of you groups can share their experience, the teams. GIAN course GIAN GIAN
रेडी सर, टच हो गया।
कोई नहीं रहेगा।
See, sir, after it has reached, now it is coming. So this is the peak load it has reached. It is actually measuring the load.
Now, this is actually this is a time-dependent car. This is time-dependent with along with loading kilonewton. This is the maximum load it takes. Okay, 269.3 kilonewton. Okay, so this is my peak compressive load. That's the maximum load it will taken. So by this 259 divided by the cross-sectional area of the specimen, you can easily calculate my compressive strength of that specimen.
What is the strain rate you think?
Not strain rate, sir. Stress rate. Stress rate. You have to calculate. You have to calculate. This much of load we have applied in 137 seconds. So from that you have to calculate. This is my stress rate. You can control this stress rate also. So this is also important thing. If you apply more stress rate, you will get a lesser load. Okay. From this card also you can find here there is a slight failure occurs. If you do not do with this data logger, you will not see this type of failure. This is a slight failure. This is we call as a local failure because of some different material existed in the specimen. This type of failure is occurred here. Okay. Experiment we have already conducted. This is UCS. So you have to test at least 5 to 7 specimens to get a to confirm that the Charnokai of this area with this much of depth with compressive strength is varying from this value to this value. This range you can give the range of. Okay. For that you have to conduct 5 to 7 specimens. And from that 7 specimen, from that failure pattern, you have to discard or accept the value. Is that clear? So now we will conduct. But in triaxial, to get the value, in triaxial we get the shear parameters. That is cohesion and angle of internal friction. To get C and phi value, you have to conduct at least 5 specimens with different confining pressure. Suppose this is your specimen, you have to prepare at least 5 specimens to get the triaxial strength parameters. Why? Because you have to apply confining pressure different on different specimens. Okay, suppose you have applied confining pressure 20 bar. Confining pressure means you have to pressurize the specimen through this radius. ये इस तरह से specimen you have to apply confining pressure, and against that confining pressure you have to increase the axial load. So when you apply confining pressure of 20 bar, you will get a sigma 1. So when you increase 40 bar, naturally your sigma will change. So our objective is to get a curve of sigma 1 and sigma 3. Sigma 1 is axial strength, sigma 3 is your confining pressure. Okay. So why it is called triaxial? Because I am talking about sigma 1 and sigma 3, but this is 2 only. So we can say this is biaxial, but I am talking about triaxial. Because sigma 2 and sigma 3, if this is sigma 2, this is sigma 3, both are equal and acting opposite. Specimen is confined with both the pressure, sigma 2 and sigma 3. Okay? Then sigma 1 will be your axial. So just we show you how the experimental setup and how the values are coming. You cannot calculate triaxial parameters because for that you have to test 5 number of specimens.
This is the well, and the apparatus is
Not because of any.
yeah, you will see this kind of smoothness or
This one is because of that grinding.
with this
Specimen
one.
fell, then grinded. This go like this. So because of that here, this one occurs, not this one. These are already pre-existing minerals. Here, this is cheap already.
Means almost well, that's slightly better.
इसको ले लो. Length here already noted.
Store.
This is a sedimentary rock.
Which cell we are putting the sample? It is you have a question that in soil you are done the triaxial. The difference in soil and rock you just see. We have a complete separate machine, and the cell on which we will keep the rock, it is also separate. It is made of iron.
सेटअप करे थे
See the steps they are doing.
सिंपल डाल अभी से हाँ उठा बड़े
मगर नाफा इन लोगों को
कुछ नहीं
सब फुल चेंज कर दिया. डालो उसमें.
सेम डिसीजन डायरेक्ट नाम करते हैं
See the setup in the load platen. Take the observation. It is not straight. We'll put again this to confirm the perpendicularity of the application of the load. This is as per ISM standard. Fluid flow, we are completely sealing it with fluid.
Is he applying the confining pressure?
No. It is to
नहीं हुआ आने दो
ensure that rear pressure will not flow clearing the road.
आने दो
It will be sealed with fluid, so that in the fluid we will apply confining pressure.
ठीक है
Understood? Now the Now for the triaxial test setup, we have put different load cell. It is a 1,000-ton capacity, because we know that sample will take more load because sample is under confining pressure. So that is why we have put separate load cell. So one of your student was taking that if we vary the load cell capacity, it is not like that. Different capacity load cell have a different setup, and it is fitted with our data logger system, so you will get the data. Now after setting up all the system one after another, the load pattern will be lowered slowly and the intactness will be observed, then only load application of the load will be started. The upper platen will be important factor. Another is the precaution. In the ISM standard, the precautions are being laid down very well in the MC. You have to take care of that precaution. Warning they are given while you are preparing sample, moving the sample, setting the sample with the
खोल के फिर दो में लगा ना
हाँ दो ही है
फ्लोरे কিছু হবে না দেখানো গেলে बैठो कहाँ फोन करता
कितना देंगे एक हाँ एक ही है
30 किलो 30 बार दो
So we will apply 30 bar confining pressure to show you how much amount of load because due to the time shortage we will not be able to test it at least 3. So to show you we are testing only one. So see the response. This side.
क्योंकि चालू करो ना आपका से उठा बढ़ाओ Initially we are applying confining pressure in bar. Here you can see this is 5 bar, 6 bar. This curve is going up. This is 10 bar now. 30 जाएगा. इनको स्लो कर दो. 7 17 है. 20 23 25 धीरे धीरे एकदम बस. Okay. So in 30.46 bar we have make it constant now. It is going flat now. बढ़ाएगा. हाँ. Now we will apply sigma 1.
So we have applied first the confining pressure. We have set it at for 30.30 bar, 30.30. Now we are applying the axial load, that is sigma 1.
हो गया, ब्रेक हो गया, ब्रेक हो गया. हाँ हाँ हाँ.
Ideally, we are looking after so that will be calibrated. It is on the estimate based on the experience we see. We take 30, 50, 100, 75 lakh based on the rock. It is a very intact marble. Then we might not be able to.
bulge out. Okay. What actually confining pressure does? It compressed it. So means the specimen fell only in shearing, that is, but oblique plane. Okay. So when you are applying more confining pressure, naturally your axial strength will be more. So you have to perform 5 specimens, means 5 different confining pressure. So 5 different confining pressure means you are getting 5 different axial strength. So if you plot confining pressure in the x-axis and in the ordinate if you plot this axial strength, you get a very good relationship. And in that relationship, this is a straight line only. From that equation, calculate easily. At 50 bar, what will be my confining pressure? Or what will be my axial strength? So this is the purpose. To get that shear parameter, C and phi, this is two constant terms for a particular rock. This is my cohesion value and this is my phi value. This is the constant value. Once you get these two parameters, easily you can calculate if the confining pressure is this, my failure plane will be, failure load will be this. Is that clear? This is for traction. This is the objective of the traction. Because rock is always in a rock mass. This is a specimen taken out from a rock mass. So in that rock mass, this rock is always under confinement and also vertical load also. Isn't it? So to get that value, to get that relationship, we contact this person. This is traction. Okay? But to know the maximum shear failure load, you have to conduct uniaxial. To know what is the maximum load it can withstand without any confinement, you have to conduct that is uniaxial. Is that clear? When I say, tell me the strength of this specimen, that is means uniaxial, not triaxial. When I ask for triaxial, that means you have, once again you have to answer what will be my confining stress. In case of triaxial, you have to give the confining stress. Okay. When I ask in any text, if you find the strength of sandstone, strength of granite, strength of quartzite, that is uniaxial.
Actually, which value we find strength-wise?
Where you use the data, that is the most important. You will use the data, that is okay. Now, tensile strength. You have seen compressive strength. Now we are going to conduct tensile strength by some indirect method. Already you must have known. Huh? Why indirect method? Because to conduct tensile strength means you have to pull the specimen by holding both the ends. A long specimen, hold the specimen by some mechanical jaw. You have to hold the specimen by some mechanical jaw and then pull it. That is tension. From tension you will get tensile strength. Clear? But rock is very much weak where the jaw is pulling. Jaw jahan par pakdega, when the jaw, that is the most, specimen will fail in that area only, not in that area. For that, ISRM suggested for an indirect method. That is, what is that indirect method? You place the specimen like this, diametrical, not like this. And the specimen thickness will be half of the diameter, not much, not less. Only half of the diameter. If the diameter is 54, thickness will be 27. In that case only, if you apply compressive load, you can see, if you apply compressive load like this, the specimen will be bulged out like this. This is tension. So that is why this is called as indirect method. Means you are applying compressive load, but make the specimen fail in tension. So here, this thickness by diameter ratio is very, very important. If you make a large specimen like this, and then if you apply load, it will be compressed. Bulging out will be very less. It will not fail in tension. So for that, ideal T by D ratio is 0.5, half of the diameter. And for that, they have suggested to make some apparatus. This is called Brazilian apparatus. This method is also called Brazilian. So this Brazilian apparatus, you place the specimen this way and then apply compressive load. So what will be my tensile strength formula? That is applied load divided by the circumferential area, because you are applying load on the circumference of the specimen. Pi dt, not pi r square. This is pi dt. Okay. 2p by pi dt. Chalo.
Ready, sir? टच हो गया.
Yes, that is we have already discussed in Brazilian case that failure initiation should be from the central position. So based on that, according to the ISRN standard, the platina are designed so that load is applied. So there will be some age, so you will get this kind of fraction. And this is load cell to show you the data log how loading is.
Yes, sir. 20 ton.
Huh?
20 ton.
This is 20 ton load cell. So you see already 50 ton load cell, 1000 ton load cell, and this is 30.
20.
20 ton load cell. Per meter.
टूट गया था.
Now take the snap. Now take the snap of the material. No, in the theory we have already explained you that in Brazilian we are applying load in this direction. And we want to ensure that the failure should initiate from the center and it will propagate in this direction. So that is the purpose of determining the indirectly the tensile strength. And there is some indexing. You have to do something, some calculation, there is some equation will given. So that will correlate you the tensile strength of the rock, more or less. This is the purpose. So that load is not concentrated load. It is living on the plate up to some this theta. Suppose for this is the center. This theta. Theta কত হবে কত theta? কত একটা হয় না? 2 theta. 2 theta. 2 theta. So your failure should be in this zone. If suppose in this way it is failed, then it is indicated that there is some problem with the body test. And regarding failure pattern, you just ask. So I will tell you some other aspect of it.
This is a Charnockite specimen. Specimen fail in tension. So there is some effect of compression here up to this level, this stripping out portion, and then this portion, this major portion, you can say 60 or 70% portion. This is because of this tension. Okay. So this is we call as split failure. Already just split out. But sir was telling, if the specimen fell in like this, oblique failure, that means there must be some pre-existing weak plane on that area. Though you are applying load here, specimen fell in this direction. And one more aspect is here in case of tensile or across the weak plane. If there is some bedding plane, if this is my bedding plane. Now if you apply load along this bedding plane, it will take less load. To fail the specimen along that area, that weak area, it will be take less load. If you apply like this, it will take more load. So you have to report tensile strength along the bedding plane or across the bedding plane. This is I am talking for sedimentary rock, because in case of sedimentary rock, this type of beddings are present. Okay. So this is what about tensile strength. What actually you are asking?
Actually, I was telling when you are applying their force, so it will definitely just go like this bulge. But what about these two portions? Is there any effect?
You consider about the axis of the specimen. This is getting compressed. So this axis is getting, so this face is getting separated by because of that tensile load. This is biaxial stress basically. You are getting compressive load and this axis, consider about this total portion center. You have applied on the center only, not here, not here. So what will happen? This is like this.
Another way to tell it is fracture is propagating in this two directions. So fracture will initiate from the center.
From the center, then go up.
Because you have already been told that generation of fracture is very small. So that is here to issue. This actually beginning from idea that if your top surface are looking which type of failure is going to be. There is basically two types of failure. There is one type of failure to be of tensile type failure. So more than discouraged. So that is basically one. Because a group, they have fabricated a direct tensile setup. They have that setup. They have fabricated in their own laboratory. ইনস্টিটিউট তদন্ত তৈরি করেছে নিজের রকে সেটাই আমরা রিসার্চ করছিলাম। সো দ্যাট হ্যাভ এ সেপারেট স্ট্যান্ডার্ড।
Although it is preferable to do direct as preferable, indirect. Means you are getting some compressive load and then tensile. So
But definitely it is giving you some indication.
that is why I said
When you are using direct in that means you should
direct is always preferable.
all of the body, all of the specimen.
No,
You should apply all of the specimen.
we are applying load like this only.
Direct means direct.
Tensile.
Direct means you have to hold the specimen and pull out.
Then only the
Only in the center. Only in the center it will go like this. In case of suppose you are pulling it out. What will happen? In the center it will be dimension. This is in the center. Then maximum is coming here. Pulling out. So what will happen? You get failure pattern. In case of sedimentary rock, you are pulling from outside. That is why you are getting
It is not a matter.
preferably it will be in this zone. But you can get failure from here also because of non-homogeneous talking.
And don't forget, this is a magnified scale. This will not be like this.
How can this be?
Please first accept that this is the ISRM suggested method only, and we are implementing that suggested method according to that standard. And in that standard, definitely it's a good question that suppose I am applying load in this direction. Okay? One observation is fracture is propagating in this direction. What about this direction? This is what about this direction? Your question is like this. In about that, most probably that is why the thickness has been taken care of half of this diameter. So they are negating.
After the test, the thickness would be increased also.
No, why? Why?
Test that also.
Why?
Due to the bulging nature, not only these tensile force, you can also bulge to this direction also. Negligible amount of thickness would also be increased, sir. Why can't we test that? Somewhat negligible amount of thickness would be sure increase.
Huh? Sure. Sure.
It would bulge, sir. It would really bulge. When it is at a breaking point, it will show bulge in that direction only, sir. Because it's bulging in this direction also, sir. So it would rather take in this way.
Some effects in these.
No, he is talking about bulging in this direction.
No, sir. If the tensile force are acting in this direction, why can't it also act on this direction? That's the question. Altimeter's bulging, sir.
Why it is active maybe?
Then why don't we consider that, sir? Why don't we consider that and take it also?
Please again recalculate. We are concentrating on for this test ensuring whether my fracture propagation is starting from the center or not. If it is like this, then definitely there is some problem in the sample because you will take out. But this sample indicates pretty well that it is to the center. Okay. Now, in the standard, they have mentioned the purpose. They have laid down the objective to determine the tensile strength of the rock in this way, indirectly, and they have derived, taken into account that this amount of axial load is applied, and this is the thickness, and this is the amount of 2 theta amount on which load is actually applied, and what is the contribution of this thickness, and based on that, what would be possible sigma t, tensile strength of the rock. So that test actually statistically found viable as far as many tests they have conducted, and they have laid down that this is the tensile strength. Now your observation is, why not considering this consideration is not arise at all. This consideration not arise at all. We are only looking up to the response and what is the amount of load is taken care of. Definitely there will be some amount of reaction in this direction.
In the practical use, we don't take only core and grit test, sir. We take in the consideration of whole rock mass building. So it acts
In rock, what we do? In rock mass, we have a rock preparation laboratory. In that rock preparation laboratory, we prepare core according to our necessity object.
just for our experiments. When we go into a field and do a construction or any mine or anything, the tensile force acts in all directions which it can probably act. So
Why tensile force is acting on
no,
direction?
when it is directly acting in these compression tests, it doesn't only get tensile in the only right to left direction. It can go into further direction also, no, sir.
Not further direction, another z direction.
Another direction and something. So why can't we consider it here only and take precautions over there, sir? Why can't
Oh,
we?
there is no precaution is needed. I do not understand your question. Please clear.
Just I'm asking that. We have experienced a tensile force in this direction, sir. In this direction.
We are experiencing fracture.
Fracture due to tensile stress in this direction.
Fracture may be due to the what is the tensile strength of a rock, and at that position, at the point of tip of the fracture propagation, maybe the load has reached more than that. So the load is greater than sigma t, that is why fracture initiation started. So we are looking at sigma t.
Tensile strength.
Tensile sigma t is the tensile strength.
So just for the tensile strength examination, we have.
No, if it is not, question is clear, don't be stop. Ask question because I could not visualize your question.
The thing is, sir, always this discussions like this, when you are putting force here, whatever this grade will initiate from this angle. Okay, anyways, what it will just separate.
No, it will propagate
Yes, upwards and downwards.
over the direction of the platen only.
The thing is, he's telling that when force is acting here, some bulging will be on these two
So
faces.
maybe it is no effect. It is no effect in the fracture propagation. Do not have.
That's the another this thing. We don't need this here while calculating these things. We are in need of that. So that's
You can carry it anywhere else, wherever you require, and you do not require any exhaustive sample preparation precautions. You do not require. Though you can take care of it, but in the field, sometimes it is not possible to prepare the sample well. So there is a standards, there is care, note of warning, note of help, yes, you can say it help, that how to take care of the irregular sample also for determining the point load index. So the point load index is basically looking after to determine when I am applying load in a point radially. When I am applying load on a point radially, what is the reaction? How the fracture developed, when developed, and what is the amount that load is taken at that particular position. So this peak load have a wider implication on determining the point load index. And that point load index is corrected, point load IS50, based on the sample configuration, ideal sample configuration. So if it is sample is not ideal, you can also take care of that correction factor. Though we need not to take care of, because we are prepare the sample well for our purpose to reduce the work. So for a mining engineer, particularly even for a civil engineer in a higher project, railway embankment project, this kind of test helps very well, because in the RMR, what we just learned in the class, RMR need you UCS. To directly find out the UCS in the field is very difficult. This point load index will give you a pretty much idea, range of values of the UCS, and that will suffice the purpose to determine the RMR. So this is very simple. So in the rock classification, you have to determine, you have to characterize different parameters. So one parameter's UCS can be directly correlated with this index property of the point load. Okay. So we will multiply, there is some factor, you will get it in the literature, I will give you. You just multiply that parameter into the point load IS50, you will get the UCS directly. So the major advantage of this test setup is, it is a hydraulically operated. You will push the hydraulic jack, and the platen will be up and up. And here there is a dial gauge will fitted, and you can see how much load is taken care of at that position. Okay, so you have to be precautious to taking the load. We will fit a dial gauge. You have to take care of this. Rest is already you can take from the data. So RAM area is this base. This jack is uploaded and converted the point load. So this you are applying load. So this is the area, cross sectional area of this. हाँ, see the RAM area. हाँ? Keep your eye here to see the load distribution, load amount. Remember, we will, and before that, please take a snap of the sample, because don't forget for as a civil engineer, geotechnical engineer, rock mechanic, rock engineer to take the photo before testing. Okay? सेंटर ही लगा वन 105.12 all are in mm. So how to mark in the middle? 150 means 52. हाँ?
डायमेट्रिकल है सर, एक्सेल इसके बाद।
चलो now we are doing diametrical.
रुकना।
कौन सा रॉक टाइप है?
लोड देख रहे हैं।
हाँ, वहाँ बोलो लोड देखने।
कौन सा टाइप?
ये डायमेट्रिकल सैंपल है, सैंडस्टोन है। हाँ, वहाँ लोड देखने बोलना। एक पेनिट्रेशन यहाँ पे रीडिंग ले लेंगे और फिर टूटने के बाद ये जो सैंपल टूटेगा ना पेनिट्रेशन का।
So everyone take this reading. After that, after the breaking, then take another reading. This is the penetration reading. Initial.
70.
This is your initial reading.
70.
Yeah.
हो गया, लिख ली, हो गया, चलो गिरजो।
70.
गिरजो, बोलो वहाँ देखने बोलना। हाँ।
Whatever stress strain behavior that very nicely you can capture with this method. Our scholars is working on that. This is only what you demonstrate a regular practical work. In case of research work, we use 100 conditions MTS. Recently we have upgraded with some software.
His interest is manufacturing. You are never nervous.
Okay. Good morning to everyone. I'll be sharing a few points regarding the study that I'm conducting. It is vibration monitoring, fragmentation control and damage control in large open cast mines. So these are the few instruments that we use in this context. This is an instrumental product, Minimate Plus. We connect geophones. Geophones are basically sensors which are used to record vibration signatures This can be used for research purpose and also for compliance purpose, because there is, as all of you know, there is an institute called DGMS right close to ISM, and it is basically a police institution. It monitors the activities of mines, and vibration is a major menace in any mining area because of blast events. There are vibrations in the nearby dwellings, and the authorities of the mine are obligated to measure these vibrations. So these are the instruments with which we do it. There are certain guidelines in vibration monitoring, like the vibration cannot be more than 5 mm per second in certain areas. For different frequency ranges, there are ranges of velocity for which should not be exceeded due to blasting. Okay. This is one thing regarding vibration monitoring. Another one is VOD measurement. There are many methods of what is VOD first of all, let me tell you. There is an explosive column, there is a hole, and we fill the hole with explosive. The velocity with which the explosive column is detonating or is it burning, that is basically velocity of detonation. The unit is meters per second because of measuring velocity of detonation. One of them is in-hole continuous monitoring, in which we insert a VOD sensing cable. It is basically an electric cable. We insert it inside the hole, and the rate at which the resistance of the wire is getting changed, that is recorded in this instrument. So the rate at which the resistance is basically dependent on the length of the wire. आपको पता होगा resistivity जो है, resistance is dependent on resistivity, length of wire and diameter. So if the wire is burning, the length of the wire is getting consumed, right? The length is reducing. So the rate of reduction of length, divided by time taken to burn it, that is basically your velocity of detonation, and this is how we measure it. I won't go through in all too much detail. P-wave and S-wave velocity, as you'll be studying in your higher semesters, P-wave and S-wave are basically the sonic properties of rock. They help us to understand the dynamic loading properties of rock. So P-wave is basically primary wave or compressional wave. It travels like this, just like sound travels in air. And S-wave is shear wave or secondary wave. It travels like this, sinusoidal pattern, like sound travels in solid. There is a difference between the way sound travels in air and solid. It's the same thing here also. So we have two transducers here. We just connect it. इसको connection करके नहीं दिखाएंगे, ऐसे ही बता देते हैं. These are the connecting wires. We connect these two sensors, these two wires with these two transducers, right? And through these machine, we are receiving P wave, and we put a sample in between these transducers, and we know the length of this sample, and we know also the time which it takes to travel through the sample. So this distance divided by the time taken is basically our P wave velocity of this sample. So we do it for different kinds of rocks, and in this way we can characterize rock based on P wave velocity. It is also mentioned in ISRM standards that we characterize rock based on sonic velocity. So this was P wave. Another one is S wave. There are different transducers for this. You can see this is a little bit thinner. We put a sample here, the same thing. The machine provides us with S wave velocity. We input the length, and the time required, we divide the time by the length, and we get the S wave velocity. So these two velocities are basically used to characterize the rock. We want to understand what kind of rocks we are dealing with in blasting or cutting or different excavation techniques used by the industry people. So this is how we try to understand the properties of rock. With this at P wave, S wave velocity, we find out the dynamic modulus of elasticity, the dynamic Poisson's ratio, and with this we design our excavation and move ahead with our planning and design. Or?
My interest of what do you do? You are from which country?
I'm from Canada, but I'm Italian as my origin. My origin is Italian. I come from Canada.
You have been to some exposure to the field or
in case of P wave, what happens?
Background, BTech engineer, fine years, civil, all civil. No, there's mining.
My name is
mining industry. Geophysics.
Geophysics.
Okay, so I think you must be aware of tunnel boring machines. Okay, so you know in tunnel boring machine there are disc cutters on the cutter head, right? So we are trying to simulate that cutter head in the lab. Okay, in the field there is a rotatory motion. Okay, because tunnels are circular, TBM tunnels. Here what we are trying to do is we are trying to generate a linear motion. Okay. So this machine is called linear cutting brake. This machine is called linear cutting brake since because of its linear motion. And what we do is we try to cut a rock with the help of a prototype disc cutter. Okay. Generally the disc cutters are 17 inch in diameter, which are lying over there at the back. You can see there. These are the original disc cutters, and we have generated a prototype disc cutter. And here what we do is we record the forces which are experienced by the cutter while cutting the rock. So behind you there is one rock from one project site, that is quartzite at the bottom. Spacings. Because the cutters are arranged at different spacing on the cutter edge, and what we do is we get the forces from this dynamometer, okay, and we calculate the work done.
Don't take photo of this machine.
Try to please avoid.
Don't take this. Is actually indigenously developed. We have developed, so don't take photos of this machine.
Yeah, you can recording. Okay. So another thing is what we will do is we will calculate the energy consumed while cutting the rock, and the ultimate objective of our experiment is to determine the best spacing and the penetration for which the minimum energy will be consumed. There is generally a U-shaped graph generated, and the ultimate lowest point we try to determine that point for the best combination of spacing and penetration, and that is used in the cutter head design. Okay, so you see the spacings, if you will see, the cutters are arranged at different spacings. So that spacing is determined from this laboratory experiment. Okay.
Basically, this will be used before putting TBM in the field. Okay. We will calculate here how much will be the spacing, what is the rock, how the disc cutter can cut the rock. How much pressure we need, how much spacing we need.
You are a project site in charge and you are asked to design a TBM, to suggest a TBM. So, sorry?
Height of TBM.
You had diameter is fixed. Okay, you know that I have to excavate a 6-meter dia tunnel. That is given by the client. Okay, but what will be the configuration of that TBM?
What will the configuration of the machine you will use?
What will be the specifications?
What is the rock condition? So, how to simulate that? You just bring a cutter, bring a rock, put it here, and what is the spacing, what is the cutter type, what is the machine specification, we'll all find out from this machine. What is the
find out
specific energy?
What will be the maximum thrust that is required, and all those things can be determined in the
Yes, we can determine.
We can apply the stress.
Yeah, you can apply the thrust hydraulically. Hydraulic thrust will be applied. Rolling forces can be determined. Basically, there are three kinds of forces: normal, rolling, and side forces. Okay, so you can get normal force, rolling force, and side forces, and you can multiply by the number of cutters times the number of cutters, and you will get the total thrust and torque. Thereafter, power and RPM also.
You want to see the demonstration?
Okay, you want to see the demonstration?
डिस्प्लेसमेंट पता करते हैं, ये कितना ऊपर नीचे गया, ये कितना आगे नीचे गया, यहाँ पे प्रॉक्सिमिटी सेंसर्स है, ठीक है, और वहाँ पे लोड्स आएगा, एक्स में कितना लोड आएगा, वाई एक्सिस में कितना लोड आएगा, जेड एक्सिस में कितना लोड आएगा, सब पता करते हैं। is actually triaxial transducer is there. Okay. This one is the triaxial transducer. Okay. This thing will measure the forces in 3 directions. In one level.
Isn't any problem in the cutting process of this flat this like rotating.
Wait. ज़्यादा लोड होता है
वो कटिंग में देना इसके साथ वो स्मूथ है ना रॉक होने
हाँ रफ होने से हमको एक्चुअली प्लेन सरफेस चाहिए होगा तो रफ भी हम लगा सकते हैं लेकिन थोड़ा रफ होगा तो थोड़ा तो डेविएशन आएगा उसमें जनरली हम वर्टिकल इनकम दिख जाएगा कितना फोर्स आ रहा है क्या आ रहा है हाइट फोर्स आ रहा है
Help of these also, you can determine the displacement.
You will see this one is a wire. This will be connected here. So ये कितना भी ऊपर नीचे जाएगा पता चलता है।
ओके भाई सिस
ठीक है।
Another thing is to determine the displacement of this trolley.
On the back side of the same thing is there. यहाँ पे sensor है for safety. It will stop here only. Will not come forward. ठीक है।